Hi everyone and welcome. Today we'll be diving into the exciting world of videogrammetry, a powerful tool for surveyors like myself. We'll explore how to capture high-quality video footage with a handheld RTK device and the mobile phone, transforming it into accurate 3D models. While photogrammetry excels in capturing large open areas, videogrammetry with an RTK device is perfect for situations where drone flights are limited. This handheld approach is ideal for tasks like creating detailed documentation of complex structures and even performing volume calculations of stockpiles or buildings. Now let's set up our phone. First, we open the anti-RIP client app and click Connect. We wait until our accuracy is under 0.02 meters. After that, we move to the 3Dsurvey scan app, where accuracy is also showed in the left corner. When we are ready, we start filming by clicking the big red button. It is important to walk slowly, as we get telemetry data only twice a second, so fast pace might reduce the accuracy of our result. It is also important to keep the equal distance from the filmed object throughout the whole video. Avoid any jerky movements to make the extracted images as clear as possible. Also, keep the important part of the video in the center of the frame, as the edges will not be reconstructed that well. It's very important to disconnect from anti-RIP after using it, because you do have to pay for anti-RIP signal. When we are done, we click the big red button, and now we can return to the office. We plug in our phone and transfer the data to our computer. Now let's open 3Dsurvey. First, click on Images and select Extract Images from Video. Choose your video file as the input. After that, select the folder where you want to save your extracted frames as the output. By default, 3Dsurvey will create a folder with the same name as your video. Choose Telemetry Extraction Mode. If under number of extracted frames you get around 2 images per second, stick with this mode. Otherwise, consider another option. Click OK to start extracting images. The telemetry importer opens up automatically. Here you select your coordinate system. In my case, the correct coordinate system is already selected. After you are done, click Import. The telemetry window opens up. Here you can see telemetry data for your images. If you want to get really precise results, click the GPS INS to camera offset button and enter the camera offset measurements. If you don't know what these measurements are, check the instruction manual. After that, close the telemetry window. Now let's move to the bundle adjustment step. Click Bundle Adjustment on the bottom right. We will use already selected global mode. Now click Show More. We'll keep feature detection and pair selection as default. We will, however, set Use telemetry data for orientation to No. When we are done, we click OK to start the bundle adjustment process. When the bundle adjustment is done, we can see the sparse point cloud with camera locations. Now let's do the dense reconstruction step. We click Reconstruction in the bottom right. We'll keep the default settings and start the process by clicking OK. OK, the dense reconstruction step is done. Here you can see our point cloud, made out of a bit more than 2,800,000 points. You can do your measurements and CAD drawings directly on the point cloud, but I prefer to do them on the 3D mesh. To create a full 3D mesh, choose Mesh in the toolbar and click Calculate New Full 3D Mesh. We will keep the default settings once again, so just click Calculate. Once the calculation process is over, we can see our full 3D mesh. If you want, you can now move to the CAD tab and do some measurements or draw CAD lines. This is all for this tutorial. Thank you and see you next time.